Hi, welcome to Algebra 2 Common Core. We're going to begin our unit on exponents with a review of the exponent rules from algebra. So looking at our list, the first rule is going to be the product rule. When I am multiplying two bases and the bases match, in this case both are x, all I need to do is add those exponents together and keep the same base. So it's going to be x to the m plus n. Let's do an example of each one as we go through. So as an example, let's do x to the 6th power times x to the 7th power. When we multiply that together, we're getting x to the 13th power because I add the exponents. Remember that x to the 6th just means x multiplied by itself 6 times. X to the 7th means x multiplied by itself 7 times. So when I take the product of those two, I'm going to have x multiplied by itself 13 times as a factor. For our quotient rule, when I'm dividing and the bases match, I'm going to subtract the exponents. So this will be x to the m minus n. As an example, if we want x to the 8th power, and we're dividing by x to the 3rd power, both are x's as our bases, so we're going to divide and say x to the 5th power by subtracting the exponents. For the third rule, we're raising a power to a power, and when we have a power raised to a power, we multiply those powers together. So this will be x to the m times n. For example, if we have x to the 3rd raised to the 5th power, multiplying those exponents together, we get x to the 15th power. Another way of thinking of that is x to the 3rd multiplied by itself 5 times. So x to the 3rd times x to the 3rd times x to the 3rd times x to the 3rd. So this is really just an application of the product rule, because when I am multiplying, I add these exponents together, and 3 added together 5 times merely gives me 15. The next rule is the same rule, but this time we're taking the power of a product. So x to the m, y to the m, to the nth power is just going to be x to the m times n and y to the m times n. Now to begin with on our example, I don't have to have the same exponents on the x and the y to begin with. So I could have something like x to the 4th, y to the 5th, all raised to the 3rd power. So raising a power to a power, I multiply those exponents, so I've got x to the 12th, y to the 15th. This power rule can also be applied to a quotient, in which case each part of the fraction, the numerator and the denominator, would both be raised to the m power. The next rule is what happens when we have 0 as an exponent. Remember, anytime we have 0 as an exponent, that's the result of doing a division where the numerator and the denominator actually had the same exponent. So when we subtract those exponents, it's giving us x to the 0. Now we also know that anytime we divide something by exactly the same thing, that's going to give us an answer of 1. So our rule is that x to the 0 is equal to 1. Now anytime we raise anything to the 0 power, the result is 1. The only exception to that is 0 to the 0 power doesn't actually have an answer. It's called indeterminate. For a negative exponent, that's the result of taking a smaller exponent or a smaller exponent in the numerator and dividing by a larger exponent in the denominator. So if we use our division rule, we subtract the exponents. 2 minus 6 is giving me a negative 4. But if you think about this, it means exactly the same thing as x times x in the numerator and x multiplied by itself 6 times in the denominator. So when we do the cancellation of same terms on the top and the bottom, this x would cancel with one of the x's on the bottom. This x would cancel with one of the x's on the bottom. And this is the same result as 1 over x to the 4th power. So our answer for x to the negative 4th is equivalent to 1 over x to the 4th. Our answer then for x to the negative m would be 1 over x to the positive m. So to make an exponent positive, we just move that term to the denominator or take the reciprocal of the base and raise it to the positive exponent. Let's go ahead and practice with some exercises. So exercise 1 shows powers of 3. You'll notice that I'm going to first of all start with 3 to the 1st power, which is 1. We know 3 to the 2nd power means 3 times 3, which is 9. And when I multiply by 3 again and get 3 to the 3rd power, that's giving me 27. Now if I go back to 3 to the 0, I know that anything to the 0 power is 1. But that also makes sense because the pattern shows that I needed a number that when I multiplied by 3, I got the result of 3. Now go back the other direction and think of it the same way. I need a number, 3 to the negative 1, so that when I multiply by 3, I'm getting an answer of 1. This, of course, is going to be 1/3, and that's what 3 to the negative 1 is equivalent to. Go back one more step. 3 to the negative 2 is going to be 1/9, because I needed a number so that when I multiplied by 3, I got 1/3. Finish it off. 3 to the negative 3rd would be 1 over 3 to the 3rd, which is 1 over 27. For exercise number 2, we're going to start with the exponential function f of x is equal to 20 times 2 to the x. So we know that this is an exponential function because it has, as part of it, the product 2 to the x power. I'm multiplying 20 times 2 to the x. Now in this case, we know that the x is only the exponent on the 2. So I can't first of all multiply 20 times 2. I have to do the exponent first and then multiply that result by 20. So we want to try this without our calculator. F of 2 just means that I've got 20 multiplied by 2 to the x, but the x this time, the input is equal to 2. Now when I calculate this, I'm going to do the exponent first, so I'm going to say 2 to the 2nd power is 4. 20 multiplied by 4 gives me an output of 80. Let's go ahead to part B, f of 0. That's going to mean the same thing as 20 multiplied by 2 to the 0 power. So for this one, I'm going to do my exponent again first. So 20 gets multiplied by 2 to the 0, which is 1. 20 times 1 is giving me 20. And in part C, we want to do f of negative 2. So that's going to be 20 times 2 to the negative 2 power. So for this one, that's going to equal 20 multiplied by 2 to the negative 2 would be 1 over 2 squared. So that's going to be 20 times 1/4, which gives us a final answer of 5. Go back over those examples. If you have any questions about them, please see me in the morning. For part D, it says when x increases by 3, by what factor does y increase? So I would like to pick two x values that are 3 apart. So for example, I could pick x equals 1, and if I increase it by 3, I could also look at x equals 4. Let's take a look at the outputs for each of those. So f of 1 would be equal to 20 times 2 to the 1st. 2 to the 1st is 2. Multiply by 20, and that gives us 40. Now I'm going to do f of 4, so 20 times 2 to the 4th power. Again, let's do our exponent first, so 20 multiplied by 2 times 2 times 2 times 2 is 16. So that gives me an answer of 320. Now, what you'll notice is that my x's increased by 3. So I added 3 on to my x. This is just one example that I could have done. I could have picked any x values that were 3 apart. We want to know what factor my y value increased by. Well, factor means what do I have to multiply by? So from 40 to 320, I see that I am multiplying by 8. So the factor that I am increasing my y by would be equal to a multiple of 8. Now if we think about this, why would this answer make sense? Because if we are going from an exponent of 2 to the 1st to an exponent of 2 to the 4th, we're actually multiplying by an extra 2 to the 3rd. But 2 to the 3rd is equal to 8. So that makes sense that we're increasing our answer, our y value, by a factor of 8. In exercise 3, we're just going to practice with our exponent rules. In all of these cases, you'll notice that the base of the exponential is 2. So that base never changes. 2 to the 3rd times 2 to the 4th. We see this as our product rule, so we keep the 2, and we add the exponents together, so it becomes 2 to the 7th. In part B, 2 to the 6th times 2 to the 2nd. Bases match, so I keep that base of 2. I add my exponents, I get an 8 because I see that I'm multiplying with exponentials. In part C, 2 to the m times 2 to the n. I keep that base of 2, but this time I add my exponents together, so m plus n. Now that multiply rule applies whether my exponents are positive or negative or fractions or integers. So in part D, I'm multiplying 2 to the 3rd times 2 to the negative 1. So I'm going to take my base of 2 and keep it, but then add those exponents together. 3 plus negative 1 gives me 2 to the 2nd power. Now in parts E and F, this time we're looking at the power rule. So the power rule says that when I am raising a power to a power, I need to multiply those exponents together. So it's important that we recognize in each case what rule is being applied. So when I multiply those exponents together, I'm getting 2 to the 12th power. And when I multiply 2 to the 5th times 2 to the negative 2nd, that's giving me 2 to the negative 10th. I'm sorry, I said that wrong. That should be 2 to the 5th raised to the negative 2nd. And I multiply the exponents to get 2 to the negative 10th. Now, usually when we have a negative exponent, we're going to rewrite that with a positive exponent. So that would be equivalent to 1 over 2 to the 10th power. In exercise number 4, the only thing that's changing is that our bases are now variables instead of the numbers 2 or 3. Some of them will have coefficients, though. So in part A, I'm multiplying a to the 6th times a to the 2nd. So I'm keeping my base of a, and I'm adding my exponents and getting a to the 8th. In part B, x to the 5th times x to the negative 3rd. I keep my base of x. When I add the exponents together, 5 plus negative 3 gives me a 2. Now notice in the third example here that these exponential functions each have coefficients. So when I am multiplying, I want to multiply the coefficients first. So 3 times -7 gives me -21. Y to the fourth times y to the second. I keep my base of y and add the exponents together. So my final product here is -21 y to the sixth. In part D, I'm raising a power to a power. But not only does the exponential b to the fourth get raised to the third power, the 2 also needs to be raised to the third power. So I'm going to write this as 2 to the third multiplied by b to the fourth raised to the third power. 2 to the third is 8, b to the fourth raised to the third, b to the 12th. And that would be my final answer for the simplification. In part E, I've got to be very careful when I'm raising a negative coefficient to an exponent, especially an odd exponent. The whole number -3 will need to be raised to the third power. And then I'll also raise x squared to the third power. So -3 to the third power, you can think in your head, it means -3 times -3 times -3, which of course is -27. When I raise the power to the power, x to the second raised to the third, that's going to be x to the sixth. Now in part F, we have our quotient raised to a power example. So each part in the numerator and the denominator will need to be raised to the fourth power. So 2 will be raised to the fourth, x squared will be raised to the fourth, and y to the fifth will be raised to the fourth. So when I simplify each of those, 2 to the fourth means 2 times 2 times 2 times 2, which is 16. X to the second to the fourth means x to the 8th power, over y to the 20th power. Multiply the inside exponent times the outside exponent. Now to finish it up, let's take a look at exercise number 5 and see if we can think about this kind of in the other direction. Now I'm given the base and I'm given the answer for the exponential. I want to see if I can think about what the exponent would have to be. So in the first case, I want to know what power 3 has to be raised to get 243. So if I start by multiplying, I know that 3 times 3 is 9, times another 3 gives me 27, times another 3 gives me 81, times another 3 gives me 243. So that means that I have used 5 factors of 3, so my exponent must have been a 5. In part B, I've got 4 to the n is equal to 1 over 64. Well, just thinking about my powers of 4, 4 to the first is 4, 4 to the second is 16, 4 to the third gives me 64. But since this is 1 over 64, that tells me that my exponent, rather than being a positive 3, must be a negative 3, so that tells me to take the reciprocal of 4, 1/4, and raise it to the third power. In part C, 6 to the n is equal to 1. Well, the only way that I'm going to get an answer of 1 for an exponential is either if my base is 1, which it's not in this case, it's 6, or if the exponent is equal to 0. So n must be equal to 0 because I know that 6 to the 0 power is equal to 1. To finish it off, let's look at 2 to the n is equal to 16. Start multiplying 2's until we get 16, so 2 times 2 is 4, times 2 is 8, times 2 is 16. But again, I see that I have a 1 over 16, so instead of using an exponent of 4, my exponent must be negative 4. So 2 to the negative 4th power is equal to 1 over 2 to the 4th power, and that, of course, is 1 over 16. Make sure that you review all of these rules for exponents before coming to class tomorrow, and we'll be practicing some of these in class. If you have any questions, please come and see me. Have a great night.